let's solve this problem. If y equals log x to base a, what will dy dx be? So this is on differentiation or differentiating logarithmic function. So this function y equals log x to base a is called a logarithmic function. The first thing I'm going to do will be to increase y by change in y, an infinitesimal change in y, and noting that this must have come from log to base a of x plus an infinitesimal change in x. Thereafter, the next thing I'm going to do will be to make change in y the subject of formula, and when you make change in y the subject of formula, we are going to have log to base a of x plus change in x minus y, which is log x to base a. So I'm going to bring this in place of y, log x to base a. Now, by the subtraction law of logarithm, this will simplify to change in y equals log to base a of, in bracket, x plus change in x all over x. This further can be simplified to give you log to base a of x over x plus change in x over x by common denominator. And this simplifies to give you change in y equals log to base a of 1 plus change in x all over x. Noting that we have now obtained the expression for change in y, the next thing we are going to do will be to obtain change in y all over change in x, which is the gradient function. To do that, we would have to multiply this expression on the right hand side by 1 over change in x. So we end up having 1 over change in x times log to base a of 1 plus change in x all over x. Here we are going to simplify further by making an introduction that helps us simplify the problem better. So I'm going to put here 1 over x times, in place of this, x over change in x. And you will see why that is needed eventually. So this will be plus change in x over x. Now, I am going to do a further simplification of what I have here by taking x over change in x through the law of powers in logarithm to become an exponent here, leaving 1 over x. So this becomes 1 over x times log to base a of 1 plus change in x all over x, all raised to the power x over change in x. At this stage, within the bracket here, you would notice that I can do something to change in x over x by taking the reciprocal, and this will give me change in y all over change in x equals 1 over x log to base a of, in bracket, 1 plus 1 over x over change in x, all raised to the power of x over change in x. So the next thing we are going to do from the last result will be to recall. We are going to recall that this constant e becomes stable as p tends to infinity of the expression 1 over 1 over p all raised to the power p. So how does it apply to this problem? We are going to take the limiting value of the gradient function change in y over change in x to get the derivative of the function. So dy dx is the limiting value of the gradient function change in y all over change in x, as change in x tends to 0. This implies taking the limiting value with 1 over x coming out, since it does not apply to it, of the limiting value as change in x tends to 0 of log to base a of 1 plus 1 over x change in x, all raised to the power of x over change in x. Okay, now that implies that you would end up having this as your result. The y dx will be equal to, this constant becomes stable. You would notice that as p tends to infinity, if p tends to infinity, then change in x will be tending to 0, because in this case our p is x over change in x. So if p tends to infinity, it would be coming from change in x tending to 0. So that would imply that 1 over x, limiting value of all these, will give us log to base a of this constant e. So you end up having dy dx as 1 over x log e to base a. Now, if a becomes e, what does your result become? It means that dy dx will now give you 1 over x, since log e to base e would give you 1, and 1 times 1 over x will be 1 over x. That solves this problem.